Okay, so today we will do sit down. We'll do AFL2, AFL3 lah. Let's see how things go. Bro, somewhere. Then you want Timothy to smell your. Then keep it somewhere. It's not it's not. This is a school, it's not a dormitory. You every time put your clothes there. I also sweat a lot. I bring 3 shirts. I throw inside after I done. I don't do this like you. Because I wash at the sink there. You wash, but it's not ideal. Keep it this. Yeah. Please be considerate. Huh? Timothy has done no wrong. He doesn't deserve to smell your shirt. Yes. Maybe Jaden Lloyd can. Okay, like that, we see how things go. Let's see how things go. We try our best. I think your class has a lot of talented people. So many people are missing. But okay, it's okay lah. We do what we can, huh? Well, I think the Seagulls got third. CD. Last time I took part in SEA Games. Then we never win. So then people say we went there in SEA Games. Yeah. Go. Okay, better. Okay, just remember to sub P as 2 and not 2000 because it's P1000. So if you are substituting P should be 2. If you sub P as 2000, you will get a negative value. Okay? Yeah, just take note, be careful. P should be 2, not 2000. P should be general. I push a bit. Careful. It's not your table, not fat people friend. A should be 3, B is a long. Yeah, I think so. A equals to 3, B should be ln. Yeah, correct. Or negative ln 2. Okay? Can So, correct. Whose bag is this? Why are you not seated? Oh, this one doesn't feel like a lesson, feel like console. After that, you need to find dp dt. What about Ophelia? Where's Ophelia? To take the class attendance today. Huh? Thinking position. It's just sleeping or something. B should be A, yeah, okay, correct. Then so what you want to do is you want to find for part 2. You want to actually it shouldn't be part B, it should be part 2. It should be a rate of change, right? They're asking you for the rate of change. So this is AFL2. Remember AFL2, the question is about rate of change. So the rate of change of the population should be which derivative? dp dt. Oh, so what you might want to do is you might want to do dp dt. Differentiate your population with respect to time. Okay? Differentiate your population with respect to time. Yeah, you're done. That's wait. Then after that, after you find your dp dt, no, I think it's fine. I think it's fine. So after you find your dp dt already, substitute. You can sub t equals to 1 and p to be 1.75. You should be able to find your value. So I think your answer should either be. Sorry. One part 2, right? It should be negative. I think it's negative 0.0108 thousand birds per year. 1,000 birds per year. Okay, Hannah. Most of you seem to be doing well, so I'll just go through very quickly. Yeah. Okay. Slowly. Now, if I'm without the use of a calculator, find the value of A and B. So here, I substitute T to be 0, P to be 2. Because initial means time is 0. So E is equal to 2. Okay? So with that, you sub 2 equals to half A plus E power 0. 2 is basically half of A plus 1. Multiply 2 to both sides. 4 is equal to A plus 1 and A is equal to 3. Okay, that's how you find A. After that, you find B. Oh, so after that, you find B. So second part, again, you sub P to be 1.75. Half A is 3 plus E to the power of B times 1. Okay, so then after multiply 2 again, 3.5 equals to 3 plus E power B. You have E power B equals to 0.5. B is just log R. Okay, so that is for part 1. Part 2, you're supposed to find the rate of change. So what are they asking you? Remember, this is about AFL2. AFL2 is what's the category is a connected rate of change. So from part 1, part 2, right? You know that if this is your P, substitute in the A and B. Yeah, it's half of A is 3 plus E to the power of log. You want to call it log half or negative log 2 is up to you. I saw a lot of you write negative log 2, so I'm going to follow this. Okay, negative log 2. Okay, after that, I differentiate. Okay, I differentiate. Differentiate 3 will give me 0. Differentiate, remember, e to the power of fx is times f prime. Okay, then so dp dt will be equals to half of negative log 2 times e to the power of t negative log 2. That is your dp dt. So over here, then you sub t equals to 5. Right? This entire sentence, what are they asking you? They are just asking you to find dp dt at t equals to 5. Okay? And if all goes well, your beautiful answer will be 0.108. 0.0108. Okay? And okay, so I'm recording for the lesson. So now I'll just go around and check on you. Sorry. If I knock bottles, I say sorry first. Yes, correct. So, okay, correct. What about question 2? Per year. B got two answers. B got two answers. Why do you have two answers for B? So ln half is the same as negative ln 2. Ln half, okay, so because remember ln 2, ln half, right? Can I say it's the same as ln 1 minus ln 2? Yeah. So it's the same as ln 1 is the same as 0, in general, ln A is the ln A is negative ln A is the same as ln of 1 over. Okay? Okay. Okay. You're done already. Which question are you doing? This one. Oh, you're asking this one.
Why? Can I not solve it if I put ln half t? If I put it as ln half t instead of negative ln 2?
Yes, no issue. Okay, so because you see, if you can e to the power, you say ln half, right?
Yeah.
Just now I wrote ln 2 because I see a lot of people write ln 2. Okay, so if I differentiate this, right? Now remember e, you guys see, e to the power of fx.
Yeah.
By right is f prime. Okay, so now I ask you, if this is fx, what is f prime? Which is just it's just ln half.
Yeah, just
because you differentiate is a polynomial. It's just ln half. Ln half. This is the f prime. E to the power of ln half. T. Can I? No issue. No issue. It's the same. This is the same as this. This is the same as negative ln 2. E to the power of negative ln 2 multiplied by time. Okay? Zoe. So this question, maybe remember that in a connected rate of change, we sometimes need maximum, we sometimes need similar triangles, Pythagoras theorem. So there was one question in your notes that talks about Pythagoras theorem. Do you want to check it out? Okay, if not, it's okay. The answer is 0.0108. 216, something, you got double of the answer. Maybe you check it. Okay. So, let me check with you. Okay, you can't. Let's look at this one. You miss out a half. You miss out a half in front. Okay. Okay, so next one. Let me go to this question. Okay, connected rate of change. You don't forget, like there are three derivatives. So one is given, one is hidden, one is the price. Okay, so what is the given? The given 0.4, right? What is this? What derivative is this? Maybe we want to just call it x, for example. This one x, this one y. Can? And the hypotenuse here is 5. Okay, so after that, dx dt, because this is going away at 0.4 meter per second. Is it okay? So that means I'm trying to tell you that dx dt is equal to 0.4 meter per second. Is that okay? Then what do they want? How fast is the speed falling? They're asking you how fast is this changing. Correct or not? So what do they want? This is the one that is given, which is the one that is the price. The price is dy dt. So what is the hidden? What's the hidden? The hidden is none other than dy dx. You can find dy dx. You can find dx dy. Either one is okay. So if I want dy dx, I will need y in terms of x. Okay, I need y in terms of x. How can I get y in terms of x? Yes, correct. Y is equal to square root of 25 minus x squared. And you'll find dy dx. Okay? Huh? But why is it for yes. Correct. Is it you did dy dx already? You do dx dy. You where you where you yes.
Like if you put dy dx, it's just
Correct. But these are specific values. When y is 4, x is 3. But y will not always be 4. X will not always be 3. Because the height and length is always moving. They're always moving at a certain particular time. Okay, but at the time where it is 4 meters, they want to ask you what is the speed of the ladder falling. Means how much is this changing? Okay, how much is this changing? So we analyze this based on the rate of change question. Huh? Again? No need. Because so the ladder is already given. It's 5. It's a bit different from the notes. Okay? And so define this as x, define this as y. Then slowly lah. Okay. If I'm not wrong, the answer is negative 0.3 meter per second. Okay, you use Pythagoras theorem. No. Okay.
Because if the ladder is 5 meters long, and then the when it's falling, it is 4 meters above the ground. So it's 4 and then 5 here.
Yes.
So x is the vertical. 3 meters is the distance is air.
Which one? 3 meters the distance is air. I'm asking you about this one. How fast is this changing? The speed, the height indeed is 4 meters, but is the speed of the height falling 4 meters? We are asking about the speed of it changing. So may I bring your attention to look at this question? Okay, so you need to use the connected rate of change. You need to think about Pythagoras theorem. Okay. Okay, so after you differentiate, right? Now, then, Dorcas, look at this. You realize that, my dy dx is in terms of x. But then what am I given? I'm given y, right? But it is okay. So what do you do? Very simple. Yes. So, no. Oh, so okay. Or, very simple. You can flip it, or since y is 4, right? Dorcas, very easy. If y is 4, ladder is 5, x equals to 3. You just sub x equals to 3. You use x equals to 3 as your currency. Easier than flipping. Yes. So, yeah. So, then you shouldn't be substituting x to be 4, but x should be 3. Okay. But yes, you are also, because whatever it is, your currency is x. 对不对？你现在有的是 x So, I ask you, if let's say you flip, right? Then, you look at your dx, is it in terms of x or y? Is it in terms of x or y? It's still in terms of x, right? That means who should you be subbing in? Should you be subbing a value of x or a value of y? 如果都是 x 的话，我要放进去的是一个 x value 还是一个 y value? X 对吗？ 4 is it an x value or a y value? Yes. Also can. That's also one way. Or yes. So Mitra, that's what exactly what I just sub x equals 1 to be 4. Sitong will get x to be 3. So Sitong, you sub x 3 instead. Can on. Yeah. That's the question 的重点. Can doesn't mean every money.
X equals 3, right?
X equals 3.
Didn't I get that from Pythagoras in the start?
Yes. But you got this, but you need to use this one. This is the one.
Yeah, this one was like preliminary.
Oh, that's good. For part B, part 2, 0.108 thousands per year. I'll write the answer in a while, very quickly. Thank you, Miss Ng. Have you done your topic 5 assignment? Yeah. Anyone haven't do? But tomorrow can? Can but tomorrow can? Which one done already? Can Fully done? Bacon done? Very good. The rest, Wisdom done? Topic 5 assignment? Finish the whole thing. Finish the whole thing. Sorry, who was asking me a question just now? What's the meaning? The meaning is that basically the rate of change is negative 0.108. That means the birds are dying. They are dropping in population at 0.102 thousand birds per year. Yes. Which one? 2 or 3? This one? 2. Now. The speed is oh yes, all right. This is the derivative. This is the derivative. Yeah. Okay, so this derivative. This is the dy so to speak. But when you write it out, the rate of speed, the speed itself, the speed of falling is 0.3. Yes. Okay. So okay, but we are talking about Jaden Lloyd is timing rate of change is going at negative 2 meters per second. Okay, no, for example, Jaden Lloyd, his timing change is negative 2 seconds. See factor of slow. His timing change is negative 2 seconds. You are getting faster, right? Because your timing is now shorter. Jaden Lloyd is cutting his timing. Has cut his timing by 2 seconds. Because this is the difference in the way I see it. One is in the direction, one is not. So when I say that speed of falling, there is already a direction. Can I? Speed of falling, I already say that it's falling. That's why you don't need to add negative sign. Oh, that's the context. What's Jaden Lloyd's timing? Nobody will say, minus 2 seconds. No. People will say, he cut timing by 2 seconds. Yes. Bao fan. For which one? Question 2. Okay. What's the pi r square times height? That's it. And I find out what is your y and what's your x? Y is so here, right, this is your y, right? Here, right, y is equal to 4, not x is equal to 4. Actually 3. Because your y is equal to 4, right? 4, 5. That's the 重点 of the question. That's the reason why we put the question inside. Okay. Mitra, 1/3 pi r square times height. Yeah. Yes. How to do is it? How do we start? Okay. the idea stays the same. Number one, you know that it's a connected rate of change, right? You will try to find three derivatives. Yes. Now, it's been gone so long since Ben. Okay. Okay, go. Okay. So okay. You remember, in the notes we got say that sometimes you need a few tricks. The few tricks could be like mensuration, Pythagoras, similar triangles, trigonometry. So here, what do they want? First, I work backwards from the question. The question wants dk dt. Right? It's always three derivatives, like follow so like that. You want dk dt. You need dk dt. The price is dk dt. Then what is given? What is given? dv dt. Can you find dv dt for me? Tell me what is it? Very good. The given is dv dt. So then Jun Kai will ask himself, if I got dk dt, then what is hidden? What do you need? dv over dk. Okay? So now Jun Kai look at dv over dk, then he will know that, hey, okay, that means I will need whatever you ask me, I need. You want me to cook fried rice? I need rice. You want me to cook noodles? I need noodles. You want me to find dv dk? I need v in terms of k. I will need v in terms of k. Can I find v in terms of k? So that's why just now Mitchell was asking around, oh, what's the volume formula? What's the volume formula? Okay, so volume formula basically is a wanted, correct, wanted pi r square h. Okay, let's commit that to memory, shall we? So this is wanted pi r square h. So volume here is wanted pi r square times h. What is h? So based on here, they say that the depth of water is h, right? So I look at this h, okay? Very good. H is 5 minus k. Yes. Usually, volume versus height. Because k is a length, right? I can just take 1 over d k. I put volume in terms of k, right? So now based on this, right, and then I see, okay, how do I get v in terms of k? First, h, right? I know that h is 5 minus k, right? That's the first one. Second, the trick heroes here, similar triangle. So using similar triangle, r over 2 is the same as h over 5. Okay? So r over 2 is the same as h over 5. R is 2 over 5h. Okay? You don't need to prove AA, 2 pairs of course, don't need. By the time you do that, by the time you do, your grandson already born. Just write down by similar triangles. Okay? By similar triangles. Okay, I hope you see that. Let me just highlight it again for you in case you didn't catch. R over 2 is the same as h over 5. Okay? Look at how similar they are. How similar they are. Okay? Like full peas in a pot. Okay? And from here, volume now will be 1/3 pi. Now my r square is so, it's like what he has bought makeup already. See, now it's so beautiful. 2 over 5. I change my r. Okay, can I change it further? Yes, I can. So it's 1/3, or basically 4 over 75 of pi h cubed. Or should I say 4 over 75 of pi 5 minus k cubed. Remember? We know that h was 5 minus k, right? Beautiful. Just like this. Which one? Is it not 25? What do you mean by 25? 5 square, but there's a third outside. Because it's a cone. 1/3 times base area times height. Oh, remember, Mitra? 1/3 times base area times height. Base area is a cone. It's a circle. Okay? Now from here, then you find your dv dk. So Jun Kai, I brought you up to this here. You walk the rest of the journey yourself. Okay? Can I? If all goes well, your answer should be 2.55. 2.55. Okay? 2.55 cm per second. Chloe doing good. No need to do product rule, by the way, because it's a constant. You know what I mean? You know, this one actually is just a constant. So don't have to work so hard. Yeah, just walk around if you don't mind. Yes, after we differentiate, we can sub K. We differentiate first. Okay, so K, where I sub K, right? Take note that you are subbing based on H. H is yes. So K should be 3.75. K should be 3.75. Okay? Sorry. I too fat. You help me check again. I think it should be correct because just now I did with O4. They all can get. So that means there's some confluence there. Okay, so one. Which one? 2.55. 2.55. That is 2.55. Can get? Cannot get? Can get. Very good. Megan, confluence one. Can get. Yeah. Once again. How do I do dV/dk? Okay, so now I come to this portion. Okay, so you got this, right? You got this, right? Oh, okay, dV/dk very easy. Okay, so first, when it's dV/dk, right? Which variable do you look for? Look for those with k. All these are Zoe. They are just extra noise, constant. Put them outside. Okay, so this is the same. Okay, ignore all these. But this one you differentiate. Okay, can you see there's a k inside? Can you see got power 3? Differentiate power 3 first. Differentiate what's inside. Okay, that's good. That's another confluence. Okay, dV/dk will be 4 pi over 25 times 3 times 5 minus k power 2. Sorry, let me adjust the 5. It looks a bit like 6. So, 75. Yeah. Oh, yeah. Sorry. Let me see whether the cancelling function works. 7. Okay. So that gives me negative 4 over 25. 4 25 pi. 5 minus k squared. Correct? Yeah. Yeah. Negative 8 over pi. That's okay. That's okay. Yeah. But remember, when they're asking you for a rate of increase, you must say the rate of decrease is 8 over pi. Okay? Negative 1. Because when you differentiate, there's this chain rule that comes up. Then after that, then you substitute at h to be 1.25. You sub your k, like your k should be 5 minus 1.25, which is about 3.75. Okay? Okay, that is very good. Then after that, let's come back to the notes. Let me know where you are at. Let's target to reach 4.7. Yes. After that, can you self-mark? Okay. Answers are on the board. Let me self. Yeah. How do I decay dt? Decay dt, after I got this, right? Okay. dk dt from the connector rate of change. dk dt is the yeah, that's the price. That's the one that you're finding, bro. Okay. Then go from the start for question 3. Okay, so question 3, first, let me write on the board. Okay, first of all, okay, let me go from here. I work from the beginning. What's the goal? The goal is to find dk dt. You know, so this is the price. The price here, the price is to find dk dt. Okay. So then after that, who is given? What is given? Given is dv. Okay, over here. What is given? You tell me what will you need? Volume over times 2. dv over? dv over dk. Can you see from this 2 k, dk? Because you want dk dt, right? The last one that's hidden is dv dk. You see, okay? Yeah. So later I let copy. You listen to me first. Yeah, I write out for you nicely. So you see, because you got k, you hit this one dv dt. So how do I know what do I need? How do I know what do I need? Is that this is my goal. Correct? This is what I'm given. Correct? You look at this, right? K must be at the top, right? So K must be top. This must be cancelled off. So this must be the bottom. That's how I go. In this one. Okay. So when Xiang looks at this, he knows that it's dv. And you will need B in terms of K. Okay. This means that our need B as a function of K. So when Xiang looks at this cone, is volume a function of K? At the moment, it's not. At the moment, oh no. Okay, for example, as a function of K. So, K. At the moment now, the volume is 1/3 times R squared times time. You see, okay? The volume is over here. This is the volume. Look. Look at this beautiful volume of the water. Yeah. Okay, see this one is the radius, this one is the height. Okay. Okay. Now, can I just share with you? Yeah, this is R. Okay, let's say you look at similar triangles. This is R and this is 2. This is 5. And this is H. Agree? R over 2 is H over 5. Agree? Okay, so by similar triangles, R over 2 equals to H over 5. Okay? Which is what I wrote on the left hand side. Okay, now, which is the same as R to be 2 over 5. Is it okay? I call this equation 1. At the same time, look at the diagram. You can see that H is also equal to 5 minus K. Let's call this equation. Okay, if your endpoint is clear, the universe will bring you the steps to get there. Oh, so remember, this is our endpoint. This is what we want. From here, right? Sub to this. Sub this to this. Sub this to this. Okay? So what I say? Yeah. R, you sub here. H, Okay, so this is the same as 1/3 times I times R squared times. Okay, wait first. Which is the same as 4/75 pi h cube. H cube 4/25 times 3/4. It's the same as 4/75 pi 5 minus k cube. Okay, this is my volume in terms of k. It's been a tough ride, but we got there. Okay, so with this, we find our dB dk. dB dk. Oh, here, right? Then you find dB dk. Oh, very, very hard to get here. Oh, who bought all these pipe cleaners? Okay, thanks for the enthusiastic response. Okay, anyway, huh? No, but K oils they are not available. Then something is wrong. It should be a constant. Are you doing part 5? Was you doing part 4? Which question? Okay, I get to that. I can do it. Yes. Give me a while. I come to you soon. Let me finish AFL first. Can I? Can. Go ahead. Okay. Who has done AFL can pass to Sipol after you self-mark. Okay? Done already. After that, let's come back to the notes. Let's target to hit 4.7. Okay? You may see anywhere you want today. Okay, which I think you already have done so. Okay. Okay, let me help you with it. You self-mark? Self-mark, okay. No, nothing like that. Just look at the looking. Okay. Okay. Okay, so now I go to who is still doing the AFL? And ask. Okay, take your time. It's okay. Tuan done already. Dr. Siam done. Mitra done. Sito done since 2025. Okay, so Zoe done. Xuan Han looks done also. Okay. Jaden Loy looks pretty. Okay. Okay, so now, I mean, since everyone is not here, maybe I won't do the assignment today then. So let's go to what happened? Okay, let's target to aim up to question 2, 4.7. Okay. Where are you all now? 4.4, 4.2. It wasn't here yesterday. It's okay. You at your own pace. Yesterday lesson, I think I just recorded. Looks so ugly. God. All the muscles, you put a flower. Totally makes me so confused. Yes, Mitra? Oh. Okay. Jukai helping you, is it? Okay. So question 4.2, right? After you have found B, right? Okay, if you got something like e power x, that is okay. Okay, e power. Hey, why you delete? Oh, okay, what? This correct. This one, okay, so basically this one, right, EV equals to 0, right? You get tangent. Correct or not? So EV, you go on, cosine x, cos x minus sine x equals to 0, right? It's the same as cos x equals to sine x. Divide by cos x on both sides. 1 is equals to sine over cosine. Okay, which is tangent. Okay. Tangent x equals to 1, right? It's correct, it's correct. Yeah. You're working here all correct. So what? No. Okay, it's okay lah. Your? Okay, very long. Okay. So let's journey together. So after that, you get tangent x equals to 1. Okay, e power x is never 0. This one you reject, correct? Because e power x is always more than 0. Now, if tangent x equals to 1, BQRA, basic angle alpha is pi over 4. Let's go by the usual traditional method, right? Basically, that's B quadrant, right? Tangent x is positive, therefore it tells you that x is in quadrant 3. Now, if it's in 1 or 3, typically, what will we do is we will take quadrant 1, that means x will be pi over 4. Quadrant 3, that means you go 1 round, it's 5 pi over 4. Okay? Then after that, I check the range. Okay, so I have answers first. Okay, so I check the range. Then, cannot let the range is first of all, the range. Okay, sorry, let me just move this up. The range, right, is that x is between negative pi to pi. So what does that tell you? If he looks at this, this one, okay, boleh, can. This one, wrong. It is not in the range. So if I not in the range, then I go back one more round. So if we do this, minus 2 pi. The answer that she get is negative 3 pi over 4. This is okay. This is okay. Okay? You okay? I okay? Everybody okay. So you have 2 answers. After you have 2 answers, you do check second derivative, first derivative. Yes. Why do I minus? Because your answer is from negative pi to pi. Right? So if you find pi over 4, it's out of it. So you go back one. Okay? Naturally, if you do quadrant 1, quadrant 3, you get this, right? So you remember, if the answer is too big, you minus 1 round. Minus 1 round is the same as minus 2 pi. If the answer is too small, you add 1 round. Okay? Can I? Okay, So, anyone, have I talked about second derivative test with you yet? Yes, Would anyone need me to repeat again? Okay, so some of you ask, second derivative test, is it almighty? It is not. Second derivative test does not always work all the time. Okay, if the second derivative test is 0, make sure you do the first. Okay, I think in question 4.3 or 4.4, there's one that requires you to do first derivative only. Okay. Can I? Okay. Yes. What's this? What's this? You call me a loser? All 7. Okay. Say clearly lah. 7, 6. So question 4.7. I remember to say, are you referring to 4.7? What's bothering you with 7? You got x equals to, you should have two x's. Oh yes, there's only one. Okay. So 4. Okay. Toilet. Yeah, I guess only. Okay. 1 second. Yeah, which one? Then it's wrong. Then it doesn't. Second derivative 0 does it mean it's form of inflection? May not be. Then you need to do first derivative. Okay. Mitra, I answer her question first, very fast, because she's you are faster, so you last priority. Okay. So, Megan, okay, you raise an opportunity for good discussion. So if the second derivative, right? You sub inside, let's say x equals to a equals to 0. Does it mean that x equals to a is a point of inflection? It may not be, you know. It may not be. Can I? But Paul inflection gives you second derivative 0. That's correct. Okay. So it really depends. It really depends. Okay. In life, there's something called equivalent statement. Okay. Some statements are equivalent. Some statements are not. If I'm a boy, I go to the boys' toilet, correct? But if I go to the boys' toilet, doesn't mean I'm a boy. May not be. I could be a cleaner. These are not equivalent statements. Okay. Second derivative test is like, I give you an analogy. So today, Megan want to buy something. I want to buy chocolates. Yeah, I go downstairs. My downstairs, maybe your house condo got 7-Eleven. Go 7-Eleven and buy. Okay. So second derivative is like 7-Eleven. Very convenient. But sometimes you want to buy fresh meat. You want to buy vegetables. You want to buy fruits. You cannot buy from 7-Eleven. You need to go all the way. 15 minutes to Zion. To buy. That's the third derivative test. But first derivative guarantees everything. I have everything you need. I guarantee you can find conclusive. When do I do first? When do I do second? If it's easy to differentiate a second time, then usually I just do second derivative. But if second derivative is 0, may not be. It may not be. Okay. Let me give you an example. Yeah. Okay. Megan, you copy this down. For everyone else, if you're listening, no. Every time my lesson want to go toilet. One day want to go toilet how many times? What urgent? Use rubber band time. Okay, go. Every time like that. You know Chinese got a phrase, 懒人屎尿多. You know this phrase? Lazy people is... Okay, never mind. Let's not translate to English. Okay, example, y equals to x power 4. Okay, Mitra, I differentiate one time. What do I get? Okay, so dy dx is 4x power 3, right? Okay, so Megan, now you see, if I equate to 0, what is x equals to? 0. Very obvious one. Okay, you see, y equals to x power. Hey guys, listen to this. Okay, what I'm going through came up 4 years ago in YEA. Okay, what was the question? The question says that, guys, define a function where the second derivative test fails. Okay, but it is a minimum point. So, example, I give you x power 4. You see, y equals to x power 4. It's very obvious. You draw the curve, you know that the turning point is 0, 0. What kind of point is this? Minimum point. Right? This is supposedly, if I equate dy dx to 0, it's a stationary point, right? What's the second derivative? If I differentiate one more time, 12x cubed. 12x squared. If I sub x to be 0, it is 0. Can you see? It is 0. But you can see that 0, 0 is a minimum point. This is an example where second derivative test screws up. You understand? So you cannot depend on second derivative all the time. It's like 7-Eleven. It's very convenient, but it doesn't have everything. In this case, yes. Doesn't mean all the time x equals 0 cannot. It's only in this case. In this case. You understand? No, you can bust with your friend. You can easily come up with another function. Okay, so now I go to 4.7. Which question is it? Part 1, part 2. A. You differentiate, you equate to 0. What do you get? So I think after... Yes, x equals to 1 over k, precisely. So then what's your concern? Yeah, k is a constant. So then my question is it a good idea to do first derivative? Or how about you observe? Okay, Mitra, Let me say. Okay. Don't jump into the water first. Stay at the side and see. Now look at A. Okay. What's your dy dx? Am I right to say what's your dy dx looking at now? Is it looking like this? Is it like looking like this? Or is it looking like this? The second one, very good. Now, Junkai and Mitra, let me ask you, what do you know about this guy? Always positive. What about this guy? Not always positive. It depends, right? It depends, right? So now let's see. Okay. Try equating this to 0, right? You know that x basically have to be 1 over k, right? 1 over k. I mean, a negative can be thrown to one side. Yeah. Now, check if x is more than 1 over k, what do you realize? 1 minus kx, what is it? Or in fact, you can even do second derivative. Why don't you try doing second derivative? Why don't you try doing second derivative from here? It might work, you know. It might work. My answer to you is that it's a maximum point. Yeah. And from part B, you can see why is in fact not just a maximum, it's a global maximum. If you're the local, if you if you're the local Mobile Legend champion, are you the world Mobile Legend champion? No. Why? Because you only win Singapore. Doesn't mean you win the whole world. Global maximum, like that only. But there could be a global somewhere. Yeah. This is local. This is global. Understand? In Chinese, there's a phrase, "San high, san down." You get quadratic. Quadratic is correct. So Mitra, your second derivative should look like this now. Huh? Yeah, okay. Can you check your second derivative should look like this? E to the power minus kx. Okay? Sub k meaning you can but why double prime you sub x to be 1 over k inside. Right? Because this is a second derivative, right? Naturally, what's the procedure that you will sub x equals to 1 over k? Okay? Can you substitute x to be 1 over k. So hot. You have a fan. You better. Cooler now. Better. Nowadays, the J2s always come to me. Then they say, today my birthday. Yeah, lor. So nowadays, those who say their birthday, I just spray at them. Then they all run. Okay. Smell so funny. I think you are funnier. Huh? Yes. Which question? Sorry. 4.2. So for 4.2b, you are at 4.2b. Okay. Okay, 4.2b, right? You are, yeah, leave it like that. Leave it as that. Because the question say what? Exact b. Auntie, 这个不对，这个对，这个是不是negative by God. I just point to alamak, you need to wear spectacle already.
It's maximum.
Which one?
How do I do the thing?
Sec pi over 4 is square root 2 over 2. What your description, what the thing? The table. Okay, so let me show you. Okay, so now it's like that. There should be two answers. Okay, so the two answers are like this. Okay, so wrong. Sorry. Okay, draw a 2 by 4 table. Okay, write down the x value in the center. The x value gradient should be 0. Now go to the right, you plus 0.1. Go to the left, you minus 0.1. Right? So why do you need a small interval? Because, right, with a smaller interval, you check the gradient on the right and on the left. You see if the gradient on the left is positive, the gradient on the right is negative. This is telling you that it's a maximum point. Yeah. If the gradient on the left is negative, the gradient on the right is positive, it's telling you that it's a point. But if your interval or your neighborhood is big, you might engulf other turning points. Right. So I do it surround another one, then might be going to be wrong. If I cannot, I might get like a point inflection. So that's why after that, we check. Okay, here, so we write the number, write the sign. It's not only number, but number and sign. Number and sign. This should allow you to conclude whether it's a minimum or maximum point. Why I cancel which one? No, this one is sorry, yesterday's error. Yesterday's working. Because display. Okay? 10啊？可以吗？ That's a not this one. It's a box file. Yeah. Most of the times we just do the local. But if you want to prove that the lower, you prove that everything to the root. Let's say you want to prove that in this case the maximum, right? Local, okay, all the tests so far only allows you to prove that it's a local, yeah, not a global. Yeah, so just take note if you go for tuition, all this, do not tell local. Local is something that's new, okay. Now, to prove that it's global, you must really prove that everybody to the left, for example, is negative. Everybody to the right is positive. Sorry, everybody to the left is positive. Everybody to the right is negative. That's for question 4.7. Yeah. If I can prove that, okay, let's say, 1 second. You try to show when x when x is more than 1 over k, gradient is 1 second, negative. When x is less than 1 over k, gradient is positive. That will allow you to show that it is always a global maximum. You understand? Yes. Not enough. Because you are using a small interval, a big interval. You need to show for all. Then I will ask you, what about plus 2? What about plus 10? What about plus 1 million? Whatever you do, I can always outbid you. You know what I mean? But okay. So how about what? But if I use the idea of generality, right? Okay, your dy dx, right? It looks like this, Agree? We found that at x equals to 1 over k, right? Is 0, right? But what about x less than 1 over k? Yes. And x more than 1 over k then? Yes. So if I can show that I'm the point where gradient is 0, everybody to my left has a positive gradient. everybody to my, because if there's a negative gradient, that means there's somebody higher than me, you know. If it's negative, everybody's lower than me. Everybody to my right has a negative gradient. Everybody to my right is smaller than me. I am a global maximum. So at x, okay, let me show you. 1 over k. When x is 1 over k. When x is less than 1 over k, everybody has a positive gradient. When x is more than 1 over k, everybody has a negative gradient. Yes, it's the biggest. Yes, yes. Yes, correct. Correct. Okay, so after after all I tell you, I'm going to write it here for you to see. Yeah, this is the official way to write it. Okay? Can if you try your bicep big, okay. Hold down, please. I envy you now. Yes? I think it's cause weather hot. Sometimes it's the shirt, the weather is hot. That's why they throw up. Why do you roll up your sleeve? What's the reason? It's sweaty. It's sweaty. Maybe you can do that next time also. You are. So if you are sweaty, you take a towel and put in your bag. You wipe it all the time. Yeah. So what you want to use is towel for? You shower every day in school. Only PE day. And shooting practice. So you find time in between. Remember, and don't disobey teachers. XER. No, okay. This one means X as a member. So before set notation. This one means X is a member. Is a member of the real number set. Yeah, this R means real number. See before, right? So what does Junkai? This is what? N is what? What is this? 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 What's all this? These are all symbols, right? Yeah, so this is the set notation. This means natural numbers. Okay? Natural numbers are also like counting. Hey, you learn this in J2. Okay, natural numbers are counting numbers. Right? If you learn in J2, right? No? Set notation. If it's J2, teacher will be very sad. Okay, so, no man. Set notation. Learn set notation. Do you remember? Do you remember? You don't remember? This form will be very sad. Okay. Okay, never mind. I just okay. 1 second. The N is yes. 1 second. Okay, N is natural number. Z is integer. Q is rational number. R is real. What does this champion logo look like? Anyone can tell me? No, I want to ask no, it's a bigger set. I want to ask the scholars. Yes, complex. Okay, can So natural is like this, natural counting numbers 1, 2, 3, 4, 5, 6, 7, natural number. Integer. What is not natural number? -2. Negative numbers are okay. Oh my god. Okay. So it's your test, your talent. You understand? You understand? You got a way to make everybody around you happy. Okay, so remember, okay, natural numbers, right? Example 1, 2, 3. It's like how you count. How do you count naturally? Do you count from -2? Because mark the attendance. How many people are there in the group? -2. You do that? No. Okay, so how do you count naturally? example temperature change. So here, -2, -1, 0. After that, scientists think about what does Q stand for? Rational. So there are these numbers here, 3/2, 7/5, so on and so forth. After that, there is a real number. Real number includes things like square root 2. We call this irrational number. Right? Square root 2 e to the power of 7 pi. Okay? Real number in your world now is basically whatever numbers that you have seen. But numbers that can be expressed as a fraction is called rational. Numbers that can be expressed in integers are fractions. So complex is the next world that you will see. Yeah, the imaginary number is consisting of I, X, and E. Okay? Can I? Yes. So once you got this, right? It's a local maximum point. Have you found? Have you okay? Do second derivative test. You can do second derivative test. Which one? You were asking me about something. Sorry, I keep forgetting. Because you were fast, so I neglected you. Okay, where are you now? What are you doing? Should you be doing a practice set?
Yeah, I'm done.
What are you doing?
Was explaining to me imaginary number.
Oh, okay. To imagine a imaginary number, you must be imaginative. Okay. You are done already.
If I make up a number, is an imaginary number.
Make up, you need to go and buy some cosmetics first. You're doing good. Very good. Okay, very good. Yes.
6, right? Like,
What do you mean by two?
I don't mind this one, yes. Yeah, also,
4 points.
this one, I get math errors. Like DYDX, math error. I can find local maximum. Because you got plus minus square root.
Small. IBOCD.
What's that?
It's not DYDX, it's DDX. This DYDX is a noun. This is a verb. Okay, yeah. Okay, then let me check. If I'm not wrong, 4.6 requires you all to take first derivative test.
I did first derivative.
Yeah. So A. Okay, or maybe can. Okay, first derivative test. Okay, second also can Good derivative too. What is Zirui? Zirui is in 402, right? Hey, you see you pour makeup How come your face so pink? Okay, so natural blush. So you can find the second derivative as well. But second derivative is not easy. Okay. But I don't know why.
Yeah, it's negative square root 2 plus 0.1, right?
Okay, can you check your
But this is correct because I can do this part correct. I cannot, only the minimum one I cannot do.
Okay, you're there really Rock differently. Correct. Okay.
Okay. 4, sorry, 4 minus
4 minus
0.1
can't seem to get it though.
to the power of negative 0.5. Negative 2.
Okay. So tomorrow can we do an assignment? Sean, okay? Have you started? Haven't. Today got time to do? It'll take you about 1 hour. Yeah. Why are you all gathered outside? Huh? Unlock the phone? Okay, yeah. Okay, tomorrow. Okay, listen. Tomorrow we go through assignment. Clear? You don't bring your stay outside the class. Yes. Can I? Please remember to do. Yeah, we are already behind already. You see other class, they didn't go through topic 7 already, I think. I don't know. Yeah, we need to be fast. Okay, can I? Okay. Thank you, class. Thank you, class. Ziray, yeah, now you're Ziray. So? Oh yeah, I forgot. Sorry. You go to China and do photo shoot. Wow, how much does it cost? 25, 125 Sing. This is 650啦，650。125 Sing啊。Tomorrow is Wednesday. No, tomorrow is Friday. And I'm looking for you. Today. Let us go. Oh.
Sorry. No. Huh? What? Regarding the. Huh? Who's dog? They don't talk. Yeah. When did she say okay? Yeah, I haven't got to my email. Excuse you. Why? Why must I excuse? It's in the level. Hello. Hello. Hey, I forgot my thing. Okay, one thing. Không nói được. Không nói được. Đây, cái gì các bạn đi đọc coi. Tôi kiếm những món ăn là tôi đi món này every oh yeah, this is the fourth quarter. So exciting. See over. Oh, over yes. Video you